The topic for today's presentation is novel plant-centric lighting solution. In order to address the indoor farming trends, we need to understand why the indoor farming is important. There is instability in agricultural production, mainly due to the reduced crop yield, concerned with the climate crisis, and also the unstable prices across different seasons. We have all experienced different prices across seasons. When it's the harvest seasons, the prices are low, but during the winter times and in the non-harvest seasons, the prices goes up. There's also reduced crop yield due to climate crisis. And the bar graph on the left that you see is the percentage of yield that decreases over a period of time. So there's decrease in yield associated with the climate crisis. The farming industry is faced with a challenge to overcome this crisis and ways to address this in order to minimize the prices and improve in the production yield. In addition to those features, there is also a food loss in the supply chain. There are greater distances between the production and the consumption that reduce the freshness and also harm the environment. In a recent study conducted, there was like more than 1/3 of the harvest that had reduced freshness and gone bad due to the transportation and over a period of time moving from production to all the way into the consumer hands. And on an average, there is like over 1,500 miles the food travels before it reaches the table. It was a fact that we learned through all these surveys and studies. There's also the trends of legalization of medical and recreational cannabis that is driving the horticulture industry. The list of countries that are legalizing the medical and cannabis and recreational cannabis are increasing day by day. Some of those countries are listed on this slide. So in order to effectively address all these food concerns, the need for indoor control environment agriculture is growing day by day. So the agriculture indoor is the most fruitful and optimized way in terms of applying the horticulture lighting. One interesting fact to note here in this rack system is the growers can make use of all the plant space or every cubic feet available space in their cultivation area. So the racks, by stacking up on each other, the way it's shown in the picture, the space in there is increased by 4x or 5x times. So it's not just the ground space that is used, but also the LED technology enables to use the horticulture lighting in applications where the plants can stack into the vertical rack systems. Moving on to the essential elements for indoor farm lighting, there are 4 major essential elements to indoor farm lighting. The factors to consider during the indoor farm lighting are lower operation cost, boosting growth, keeping crop fresh, and robustness. The LED lights in the horticulture environment are on for extended period of time, and therefore the energy savings are critical for a successful indoor farm lighting. In addition to that, the boosting crop by using the efficient LEDs, by keeping the crops fresh under these LED lights, and robustness are the other 3 factors that are majorly considered in indoor farm lighting. We will discuss in depth about all those factors in the next few slides. To address the lower operation costs, the LEDs needs to be designed with the industry-leading PPE for the energy saving and the efficient fixture luminaire design. The second is the boosting growth. So these differentiated spectrums and the possible with the LEDs add to the better growth of the plant. Keeping the crops fresh is associated with keep suppressing the microbial growth for the longer shelf life. And in the next few slides that we talk about, we'll see how using the Samsung LEDs will address each of this individual issue associated with this indoor farm lighting. The final here shows the robustness and device architecture for durability. Horticulture applications is one of the tough applications for the LED in terms of reliability and LED survival. So we have further down improved the reliability of LED by applying our new features into the LED using a flip chip technology, using the coatings that are applied on the phosphor that will be discussed in the next slides. To effectively address the LED solution, one of the way is to use the plant-centric spectrum LEDs. We've used the other narrow or broadband spectrum LEDs, but plant spectrum LEDs allows you to use the LEDs more efficient way and also get the high PPE or high performance results. Here we are introducing the Samsung's plant-centric spectrum. If you look at the graph here in the SPD that shows the overall comparison between the regular LEDs and the plant-centric LEDs, we have engineered this with a pump wavelength of 437 nanometer, which simulates the plant growth with the best efficacy. So the right side graph compares and shows you the SPD graph of the 437 nanometer. The highest PPE for the 437 nanometer was as a result of a bunch of experiments that we conducted, and on the right side graph shows the percentage of PPE improvement associated with the each wavelength. And as you can see, the graph with the 437 nanometers offers the most efficient way to address and design the plant-centric LEDs compared to some of the other wavelengths. So basically, the blue light energy converts into moving from 450 nanometer and covering up the 437 nanometer, effectively increase the performance of the LED. In terms of the performance number and maintaining the highest PPE, the difference with the regular LEDs compared to the plant-centric LEDs is approximately 2%. So we are with the normal plant spectrum LEDs roughly around 3.08 micromoles per joule. But with the plant-centric LEDs, we are at 3.14, which is increase in 2%, roughly 2%. The thing to note about this is the left side performance is at 65 milliamp only. But as you increase the current, the difference in the performance can grow up to 6%. So the right side graph show you at different operating conditions on the x-axis versus the y-axis, where it shows the PPE, and the smallest difference at 65, which is the nominal operating conditions, is approximately 2%, compared to as you increase the current goes to 6%. So as a designer, when I am designing the light, I would like to use the lowest power possible solutions and just try to optimize the design using the current, which can give me the high returns and high performance. So it's not a fixed rule about 2% at optimal conditions. It can vary from 2 to 6 depending on the operating conditions. So the 435 nanometer peak of plant-centric spectrum is also suitable for the chlorophyll A and B ratio and photosynthesis. As we all know, the 660 nanometer LED is much suitable for photosynthesis, and the blue peak LED, which is in the range of 435, 450 nanometers, are suitable for the vegetation and flowering stage. So here, combining the normal spectrum LED, which is the 450 nanometer peak with the 437 nanometer peak, give you the optimal results and gives you a better chlorophyll A and chlorophyll B ratio to process photosynthesis. So the importance of blue lights is not just for nutrition and vegetation stage, but also on the photomorphogenesis stage. This is the photomorphogenesis stage is maintaining the activities of plant growth by responding to the light spectrum. So as you know, the plant or the respond to the power all over the range from like 380, 400 all the way up to 780 range. So having this extra blue photons in them can help the photomorphogenesis of the plant, in addition to the developing the secondary metabolites and including the phenolics and the flavonols contains inside the crop. So this is a huge advantage that you see using with the combination of regular 450 nanometer and the 437 nanometer LEDs. In order to validate our point of using the 437 nanometer LED for plant growth, we have conducted an experiment using the two plants, which is the butterhead lettuce and the Roman lettuce. This was over a 6 weeks period with identical conditions. The temperature, humidity remained same. The only light variables that we have was the different type of LEDs as shown on the scene, which is the 4 types. So the one we're using the narrow spectrum LED, which is basically the red and blue LED. Second is using the normal full spectrum LED. And the third is using the 437 nano plant spectrum LED. And finally using the Evo Mint LED. So after this experiment, we compared the plant growth, how much the phytonutrients are developed, and how efficiently it can suppress the microbial growth inside the plant. So one interesting thing that we also notice is using the Samsung plant-centric solution, it shows less energy consumptions compared to some of the other sources. And roughly comparing from the normal spectrum, it was roughly 6% lower. And compared to the narrow, we didn't really compare the narrow. The reason being is very obvious, and you can see up to 30 to 40% difference when you compare the narrow spectrum. But comparing normal to the plant spectrum saw 6% decrease in energy consumption. When we evaluated these leaves after the experiment, they were like heavy and larger leaves that was developed with the same amount of power using the different LED spectrums here. So the 150 pp, the target was 150 ppfd, and using this 4 different type of LEDs, we could achieve with the narrow is 129, with the normal full spectrum was 161, but the highest results in the 437 nanometer plant spectrum LEDs, which was 167 and 172 ppfd levels. And this was all at 80 watts nominal wattage. We further sent down each leaves examination to see how much better the plant and differentiated spectrum in terms of percentage of growth. And it was an ooping on the right side on the leaf area, which is usually measured in like meters per plant. That was close to like 7% increase in the plant. And on the left, it shows the shoot fresh weight plant growth, and that was roughly approximately 13% that we saw increase using the 437 nanometer LEDs. So this is a huge increase. So what that allows the cultivators is to use these LEDs and be able to sell the crop with much higher nutrients and much higher biomass associated with it. In terms of the microbial growth, the shorter wavelength, which is associated with the blue length of the 437, suppress the microbial growth as well. So here shows the comparison from day 0 to day 14. And all those 3 bars that you see here are the narrow spectrum, normal spectrum, full spectrum, and the 437 nanometer LEDs. On the day 0, the separation was close to like negative 20%. And on the day 14, the separation was anywhere between minus 20 to 19%. So the separation of the microbial growth was additionally added to the features of this using the 437 nanometer LEDs. And the blue bar that you see here on the left side on the graph that's where we see those the veggies or the crops gets rotten after it crosses a certain level. So in order to maintain the much freshness of the plant growth, the microbial and separation of microbial growth, 437 nanometer was very effective. further down, evaluating deep dive into the actual photonutrients of the crops. Here shows the comparison of the narrow spectrum LED, full spectrum 437 nanometer LED, comparing the flavonol contents in the butterhead lettuce. So the plant-centric LEDs was almost close to about north of 3,000, whereas the narrow spectrum ended approximately 2,500, and the full spectrum were close to 2,000, and the 437 Mint LED plant spectrum was 2,200. So there is an whooping winner here in terms of offering more photonutrients of the crop and increase the flavonol contents in the butterhead lettuce. We did a similar comparison in the Roman lettuce as well. So in the Roman lettuce, the number was very similar, and the percentage of increase in the flavonol contents matched with our butter lettuce. So the message here is these photo using the plant-centric LEDs, they can be upwards of some like 73% in terms of using the plant-centric LEDs with the Evo Mint combination, and then with the regular Evo can see up to 97%, which is almost double photonutrients that are found into these crops using the 437 nanometer. The winners of the Amazon gift card will be announced at the end of this session. Finally, addressing the robustness of the architecture of the LED. While the LED features in terms of reliability are appreciated features, there is a huge concern when LEDs are used in the environmental conditions about reliability and robustness of a LED. To address the concern of robustness and reliability, our plant-centric LEDs and normal-centric 3030 LEDs are designed using a flip chip technology, which is the industry-proven high-performance LED. Here, the comparison is between the flip chip and the epi-up LED on the left side. So in the epi-up LEDs, there are wire bonds inside LED which could potentially react to some of the harsh horticulture environments, such as sulfur and fertilizers that are found into the environment that could potentially degrade the LEDs and yellow the phosphor over a period of time. But using the flip chip structure LED, there is no wire bonds inside the LEDs that allows it to totally eliminate any failure points associated with this sulfurs and other chemicals found in the horticulture ambient applications. So clearly, using the flip chip technology is very critical for horticulture applications. In terms of how offering the performance and lumens per watt, the flip chip technology offers much higher performance, and it runs cooler because the area of dissipation of heat underneath the chip is much higher compared to the wire bond LEDs. In wire bond LEDs, the dissipation of heat is mostly dependent on the wire chip that you see, or the wire bonds associated with the epi-up LED. But in case of the flip chip LEDs, these are directly mounted, so the heat reduction and the heat current density is much lower when compared to the epi-up LED. In addition to the flip chip technology and the advantages we saw, there is also an coating that we applied inside the LEDs that protect it for some of the high reflective reflector materials that you use inside the 3030 packages and other horticulture offerings. So the image here, the red line that you see on the image shows you that the reflector coating and how it can further optimize the chip structure for higher reliability. In order to validate the point, we did a comparison and a PPF in high sulfur environment, and this test is backed by IEC standards. So the flip chip technology had a whooping 99% PPF maintenance compared to some of the epi-up LEDs when we compare, and that ended up at 92.5 LEDs. So clearly using the plant-centric LEDs, 3030 flip chip LEDs is the winner for horticulture applications. To summarize the slide here in terms of the novel spectrum LEDs, overall we saw 6% less power consumption by using the plant-centric spectrum LED, 6% greater PPFD, 13% more robustness, 20% less microbial growth, 7% larger leaf area, and 60% enhanced phytonutrients. If any of us here would like to explore more or explore the data, we do have the backup data and test results that we can share, and feel free to stop by our booth and explore our horticulture offerings. And in addition to the reducing all the robustness, the growth, energy efficiency, there's also lower total cost system when compared to the normal spectrum LED or the narrow band spectrum LED. So it was whooping cost efficient benefit that you could also offer to the growers by lowering the cost and using the high efficient plant-centric lighting. So the total cost is roughly showed in comparison. So the highest cost that we saw was in the narrow spectrum LED, followed by normal full spectrum LED, and finally the winner was the plant-centric LED using the lower wattage. Here slide shows our Samsung horticulture offering. We offer all the way from 3030 packages, chip scale packages, high power white LEDs, and also the color LEDs. In color LEDs, we offer the blue 450 nanometers blue, all 660 nanometer, 3 different version performance, 630 nanometer, and also the 730 nanometer LEDs. Here's an interesting thing to note about the Gen 2 module that we are introducing here at Light Fair is we have now upgraded our Gen 1 module to have used the plant-centric LEDs in our Gen 2 module. And in additional comment I would like to make is like we also offer custom L2 solution. So using our LEDs here can design your own board depending on the spectrum and the performance requirements. So our board we can customize to any level using these LEDs as well. This brings us to the last slide of my presentation here. In addition to the offerings all that's shown on the earlier slides, we have a spectrum calculator or a simulator on performance that helps you calculate the spectrum, the percentage of RGB, using the selecting the different LEDs and the operating conditions. So this tool is available on request. If any of you would like to get a copy of this tool, feel free to register and send us a message. Then we'll be happy to send this tool to your email.